Welcome everyone. In this video, we will think about the basic difference between the silicon diode and Schottky diode. So these are the two very well known or very famous diodes are there. So the first one we are very familiar, that is our PN junction diode. So this one is our PN junction diode, in which this side your anode and cathode, okay, and this one is our PN junction. Okay, PN junction diode we can also call, or this one is called a semiconductor based. Okay, P and N. This side we can say P and N, and this P and N both terminal is made of semiconductor. Semiconductor. That is our P and N. Okay, so one of the example of commercially available name for the diode is 1N4007. 1N means single junction. Okay. Now another one is your Schottky diode. Okay. So the Schottky diode is 1N5820, or it may be 1N5817. Okay. So many diodes are there. So again, this one is also anode, and this one is cathode. So in this Schottky diode, this one is our Schottky diode. Okay. This one is our silicon diode, and this one is our Schottky diode. Okay, so in this one there is a semiconductor and metal junction. Okay, so basically this one is our metal to semiconductor junction, or we can say this one is this made of semiconductor and metal. Semiconductor and metal junction. Okay, not simple PN junction. This one consists of a semiconductor and metal junction. So first we have to know about some differences. So for example, this diode, okay, this diode having some cut-in voltage, say VD, I'm writing VD of silicon, okay, is generally we are saying 0.7 volt, okay, and this one for VD, okay, this one is also diode, so I'm writing VD, and in the sheet of silicon we are writing semiconductor, oh sorry, Schottky diode, so I'm just representing the VDSC. So this VDSC is quite low, like 3, 4, 5. Okay, so what we can say, the one of the major advantage, one can say the one of the major advantage is that VD cut-in voltage or is always greater VDS. Okay, or we can say this one is our what, cut-in voltage. Cut-in voltage, I am writing here cut-in voltage. Okay, for silicon points. Okay, so this one is the one of the major advantage. I'm just highlighting this one. Okay, so what we can write, short key. First point I am writing, short key diode has lesser cut-in voltage, cut-in voltage in comparison to silicon diode. Okay, so one of the major advantage of Schottky diode that have a lower cut-in voltage, okay, than silicon diode. Okay, so what it results, so if this one having the lower one, this one for silicon and this one for Schottky diode, so cut-in voltage is less, so less heat will be generated in the Schottky diode because this one is less. Okay, so power dissipation near to junction in Schottky diode will be less in comparison to silicon diode. Okay, because this one very important formula that I power dissipation CL VDD square F, simple formula, but for the means so it is just the square of the some supply kind of thing. So basically, so voltage is less, power dissipation will be less, or we can better it will write VI. Okay, this one for CMOS inverter, so better to go for this formula. PD equals to VI. So power dissipation near to the junction will be always less in Schottky diode. Okay, so in general, what we observe that if one device say 1N4007 and 1N5817 or anything means 20, okay, the current, if the current is having the same value, the current in the diode is flowing like 500 milliampere, then the cut-in voltage, okay, VD, okay, VD silicon or VDSC. Okay, so I'm writing first for VD silicon is around 0.7, okay, or it is around 0.8 in some book, 0.832 like that, 0.832. So this one is also 0.345. Okay, clear. And the corresponding power dissipation will be 416 milliwatt, and here it is very less. Okay, clear. So this one is some important observation that in silicon diode, this silicon diode, okay, it is current is around 500 milliampere, then the cut-in voltage is 0.832 and power dissipation 416 milliwatt. Okay, and in Schottky diode for the 500 milliwatt, the cut-in voltage is still 0.345, very less. So power dissipation is here 416 milliwatt and 173 milliwatt. Okay, and one more thing that it will better. Schottky diodes results a lower temperature process. Okay, here I am writing Schottky Schottky diode results a lower temperature results a lower temperature, like for this one, for if you consider this one, it has a temperature around 54 degrees centigrade and this one for 38 degrees centigrade. So Schottky diode results a lower temperature, okay, that is our 38 degrees centigrade for that 500 milliampere instead of 54 degrees centigrade in diode, in silicon diode. Okay, this one is one more definition. Okay, now, so what is the advantage? And it has also very fast switching speed. Okay, so I'm more writing. So Schottky diode having, we can also write lower cut-in. Okay, already written. So lower cut-in voltage and fast switching speed can be observed in Schottky diode. Schottky diode. Okay, in Schottky diode, the cut-in voltage will be lower and fast switching speed in comparison to also right in comparison to silicon diode. Okay, this one is our one more, or simply we can write, already we have written lower cut-in voltage in the first point, so we can write fast switching speed observed in Schottky diode in comparison to silicon diode. Okay, means what it means. For example, we have a half wave rectifier. Okay, this one is our VI and this one is our V naught R. Some resistors are the R, and we are giving some signal. Some signal we are giving like this. Some input signal. Let's say this one is our VI. Okay, VI signal with some 60 hertz frequency or better 50 hertz frequency. Okay, then in case of diode, if we are considering this as a diode one output across this silicon diode. Okay, so what we result for the half wave, for the half wave, what we result, this kind of response, yes or no, ideally. Okay, this kind of response ideally for the first positive half. Okay, but in actual practice what we can say, this is somehow, okay, wait. But in actual practice what we can do, it will come, and it will go. Okay, means this one for 1N4007. Okay, but in case of there is some small, but fast switching speed means, but in case of your what 5820 or that diode, it will very very smooth. Okay, very smooth. Okay, so means we have observed two frequency response. So this one for 60 hertz. Okay, and another one, that the black one, the black one not okay. So this one, if we do go for the higher frequency like 300 kilohertz, it will go like this. It will not give a very accurate result. Okay, but in case of this one, okay, once again I will tell, blue one for 300 60 hertz, sorry, 60 hertz, take it 60 hertz. Okay, 60 hertz or 50 hertz, anything you can take. And for the red one, it is 300 kilohertz. So the operation will be very ideal in case of in case of Schottky diode, but for different frequency, it will, for higher frequency, it will give some unwanted response. So at higher frequency, Schottky diodes is on steroids. Okay, so what we can say, at higher frequency around 300 kilohertz, the Schottky diodes, the Schottky diodes, diode, diode gives a smooth, ideal or ideal kind of response. Okay, at higher frequency, and lower frequency also it will give the better result. Okay, And the Schottky diode has no trouble at higher frequency, we can say. But in silicon diode, the rectification is not very well. Okay, rectification is not well in silicon diode for higher frequency. Rectification cannot be observed well in silicon diode for higher frequency. Okay, so this one is the example, means what we can say for the low frequency or 50 hertz or 60 hertz, it will work properly. Okay, both the diodes, silicon diode and Schottky diode. But if we go for the higher frequency, the rectification is not well in the silicon diode, but for the Schottky it will give the better result. Okay, so now, but what should be the, we can say the basic disadvantages, Schottky disadvantages, we can say. So one more thing is that we have to Schottky disadvantages. Some disadvantages is there that we have to also know. Okay, so in Schottky diode, reverse current will be high, will be high, will be high in comparison to silicon diode. Okay, it is around 20 microampere, where diode has, where the diode has reverse current will be around 1 microampere for silicon diode. Silicon diode. So, so reverse current will be high, 20 microampere in comparison to, okay, I'm writing. Reverse current will be high, okay, around 20 microampere in comparison to silicon diode. Silicon diode is around 1 microampere. So this is all about the difference between the Schottky diode and simple silicon diode. So this is the definition, means what we can say, some uh, differences of a Schottky diode and silicon diode. So thank you for watching this video.